Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Rancher.
But before we begin, let me inform you few things about us. DevOps School is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
First thing, step number 1, I am going to create one VM on AWS. Step number 2, I am going to create one cluster. And last time we tried EKS, but this time we'll try custom. So see here, Amazon EKS, Google GKE, but this time we'll try custom, and that using R key. Okay. So here, this time we'll try custom. So create a cluster, use existing node and create a cluster using R key. So this is the stuff we'll try. Step number 3, install Docker in a node. Step number 4, run commands of RK agent. Okay, so these are the steps, 4 steps I'm doing right now. So let's get started. So let's create one more VM this time and cancel, send to S7 I want, and marketplace, this is the one. I'll go for the little bit of more CPU and more RAM. That way that failures for CPU and RAM will be avoided. And here I'll go for 2 CPU for 8 GB RAM, this one. And one machine, that's more than sufficient. 30 GB hard disk, I'll just go with it. Now this one is downstream KX. Okay, down KX and security group. Now I'll just make it open everything for time being and launch. Rajesh Mumbai and done. So now I've created one machine. That's step number 1, which I did, this one. Now second step is I'm going to create a cluster using existing node and create a cluster using RK. So that's where I am going to do this command and options here. So I'm going to create a cluster here. Can you see my screen?
Yes.
Yeah. So custom, click custom. Now here I'm going to name it, this is a Rajesh 1 cluster. Now managing rules, I'll let it be as it is, not required. Labels and annotations, I'll let it be. Now Kubernetes option, the one which I'm going for is the stable one, which is 1.229, which is this one. And here, which networking policies I want, VNet. You can go any of this. And after that, Windows support disabled, of course. Project network isolation disabled. I'll let it be empty, override this one. Now, what is a cloud provider? So here I am going to use Amazon. So here there is some message which is coming. Let's see. Configuring a cloud provider in your cluster without configuring the prerequisite will cause your cluster to not provision correctly. Prerequisite needed for supported cloud platform can be found in the documentation. And private registry, I'll not deploy in this. If you want to deploy private registry, you can enable it. Advanced options, some of this stuff you have. Do you want ingress? Do you want backends? what is a node port range, a metric server enabling monitoring, and also port security policies, Docker versions, all this stuff, and secret encryptions, etcd where you want local or S3, recurring etcd snapshot enabled. So all this thing default, I'll go with it. If you want to increase it, you can do that. How many maximum workers should be unavailable, so all this thing you can set it up, and authorize endpoints, and this is also I'll make it enabled and next. So yep, just go through this. Now if you want this node to behave like a worker, you should select worker. Now this command will be installing the worker, but if you want the control plane also, then automatically this code will change. Again etcd also, so again it will change. So mind it, right now you want multi mode clusters, multi node clusters with multi control plane, multi etcd and all. You can make it all this stuff, and because not a worker, it's etcd also, it's control plane also, so I'm going for this. Now if you run it and add it like a worker, you have to disable that options, mind it, and you want to add a worker only, so you can do that. So this is the stuff, and then done. Now what I'm going to do is I am going to log in to the server. Let me log in. So I'm going to log into this machine, and that IP address is for this machine here. I'm going to install the Docker inside that. Why Docker? Remember that. See, this is the Docker command you are running. So you have to install the Docker, which is the step number 3. So let's get Docker installed. Enter. Yes. And finally Docker installation. So for that I'm going to Docker install. Here it is. So I'm installing through script. And installing the Docker. Done. Now there is one issues which we have in the Docker, and you know that that is you have to change the C group settings of Docker. So let's change this, because the latest version of Kubernetes we have that problem. So Docker and C groups, and here you have to change this. So I'm changing it. VI, and from this line to this line, and save it. Done. Finally, you should reload this and restart Docker. and command which we to validate, that is docker info. Wonderful. So Docker is installed. This step is also done. Did you understand so far?
Yeah.
Yeah. Now there is a problem here in this code. If I look at this very carefully, they are trying to run this agent against this server, and these are the tokens which we have, and the rule for is etcd control plane and worker. So if I look at this command very carefully, see that there's some error which I possibly see. This is my Rancher server, which is you can see, but here IP address, the one which is being used, it's of different. So why is that so? So basically what has happened, IP address of the server is the IP address of the server is been taken from the IP address EC2 instance public IP address first time, and after that many times I restarted the Rancher and VM box. So every time you restart the VM box, basically you will get a new IP address. So this is the right IP address, this is the wrong IP address. How do you change it? So what I'm going to do is I'm going to cancel this and go to the cluster management global setting. Okay, and this one you go to change this server IP address. So if you go here somewhere under the global setting, advanced setting, and here this IP address you have to change it. So it's if you have production servers and all these issues you will not come across, but because it's AWS which I keep starting it and stopping it, so edit, I'm going to change this IP address. So this is the right IP address, and that's all I did. It's just a troubleshooting stuff. After that, what you want to do is you go into home. Let me going to cluster management, and there is a one create. Again, same steps, custom, and this one Rajesh one, and most of the issues, most of those options I'll leave it, and private registry options, all these things you can see that, and authorization points, and next. There's some problem, name is not unique, so I'll just make it 2. Probably last time I saved it. Next, and that's all. So now this is the command we should execute it. So now if you see that IP address is got changed, and now this command you should run in that box where that this Kubernetes, basically Kubernetes will run as a master, as a worker, and stuff like that. So did you understand that how it's working?
Yes.
So I'm going to run this command, this machine, and paste it, enter. Now these images will be downloaded, and this pulling is happening. So I have a 8 GB RAM, so I'm expecting a little faster. Let's check it out. So download of images completed. Now I have got the Rancher agent Container has been created and restarting. And do you see that here now?
Yeah, I see that.
Yeah. So it's done. Now this is your command which was expecting you to run, and done. Now just wait for some time. I should refresh. Click refresh. Refresh. Here, this is the Rajesh 2 which I created, and click on it. Now you can see the logs here of what is being done. So right now it's trying to connect with that. Registrations, I did it, this command I run it, and snapshots, conditions. So you can see that all these conditions and related resources. So now this is the way you can add that machine as a cluster, Rajesh 2, and just wait for some more time. Waiting for etcd control plane and worker need to be registered. So I have run this command, and internally this will be doing rest of the stuff, and still this restarted again. You see that. So just wait for some more time, and this command will try to register the RK. Now here we need to have RKE running. So that means we need to install RKE here. So how do we install the RKE? So for that, I should go RKE Kubernetes commands. Okay, so there's one command config. First install the RKE. I'm installing the RKE, and see RKE homebrew, binaries, and all stuff like that. So download this RKE. So this is a Linux Intel AMD. This is the one. So how do we do that? So for that, you have to go to GitHub. Now the question is GitHub URL is somewhere here, and I need to download the RKE executable, and here it is. Now this dark RKE-MD4. So this is the one I need actually. So copy the URL, and I am going to OPT directory, and here downloading this file. wget is not there, yum install wget -y, and after that wget this executable, and done. chmod 755 RK Linux, and I think that was the download. After that, run into this. So I'm going to move this file name from this one to RK, and what I will do is I'll move to the path environment variable. So probably user sbin is an, or user bin also you can send this file. So mb rk to user bin. Now let me check if I have installed it or not. It's up. So I installed this utility. After that, what you need to do, you have to configure it. That's a step number 2. This is a preparations for the node for the cluster. So how do you do that? So here, so this one you can do that. Cluster component are launched using Docker distro, and you can, so here you see the Kubernetes cluster components are launched using Docker on Linux distro. You can use any Linux you want as long as you start it up. So Docker installations and all I did it. Now you are going to create cluster configurations. So for that, what I'm going to do, so I'm going to run this cube RKE config. Okay, so RKE config I'm going to run, and so for that I need to, yeah. So this is the command I'm going to run. So mkdir k8, get into the k8, and finally run this command. And they are asking you some questions you have to answer. Cluster level SSH, which one you want to use it? So I just want to use the same one. Number of hosts, that's okay, 1. SSH address, I'll go SSH address for the host, so where it should be SSHing and stuff like that. So for that, here it should be IP address actually. So IP address for this one. Enter SSH port default, private key let it be, and private key host, that's okay, and this is also okay, and yes, and worker host. Here is this the host, worker host? Yes. So I'm making the host control plane and worker host both in the same machines, and etcd, yes, and override host name of the host, that's okay, and internal IP address is okay, Docker socket is okay, and plugin I will use a weave. So for that, WEAV, weave. Enter. Authentication strategy, that's the same, and authorization mode RBAC. Enter. And what's the version, Docker image and all. So this domains, let it be same, and same, done. So this, all this stuff you have to be careful while doing it, and now after that, this is the deployment of Kubernetes RK. So this is the command you need to run to solve. So I'm going to run RKE up, and that command will do the rest of the things. So this will set up your cluster, and okay, so there's some problem. Cluster must have at least one etcd plane host. Please specify one or more etcd. So here I had selected etcd host. So let me just stop the record.
This conference will now be recorded.
Yeah, so now we are going to discuss about driving transformation with DevOps and Rancher, and deploying containerized applications with Rancher, and understanding the centralized app catalog in Rancher. So how do we do that? So there is a benefit of using Rancher is like you can implement and also transform into the DevOps using the apps which you can find on Rancher. So a key benefit of Rancher is that it helps teams securely deploy containerized apps regardless of where the Kubernetes runs. Now, the one which I'm talking about right now is of these options, continuous delivery options. Okay, so this will help you to implement the DevOps also in a Rancher environment. So yeah, Rancher works with existing tools such as Jenkins, Aqua, Azure DevOps, GitHub, GitLab, Sysdig, Datadog, Artifactory, PagerDuty, and all the DevOps enabled tools which you can think of. Now, Rancher will help you to assist in deploying complex microservices apps. Also, demystifies and simplifies deployment of services such as mesh, monitoring tool like Prometheus, Grafana, and stuff like that. So here, if you go and check at this place, here you have clusters. Let's say right now only one cluster active, and there's some problem in this also. Yeah, let's go to the local app marketplace. Here, if you see that under this repository, recent operations, installed app, and charts. These are all the places you can have all the DevOps tool which you can install it. For example, let's say I have only one clusters active, so I want to install Prometheus. So I'll look for the Prometheus, which is basically for monitoring tool. So which you can find here. This one, install this and select this all this thing, which particular projects you want. So DevOps school, next, install. Like that, if you want to install more DevOps tool like Istio, let's say, so here, install, project name, next, install. Now if you go to that project, so I'll take you to the projects here. Under projects, DevOps school, the projects, where is that? Here it is. Now all these resources you will find inside that. So let me show you in this here workload, and here see here, Datadog is installed, Prometheus and Istio. I'll show you just a second. Still not come, so I'll just have to wait for it. Let me see if it got completed. So here installed app and fleet, rancher, set manager, queue monitoring. Still, let me check. Charts. Okay, it's got installed, but this required for should be coming. Monitoring. Rancher backup has come, but it was now installed a Prometheus, so I'm just looking for it. It says probably there's some problem in the Rancher itself. Okay, let me install one more. Istio. It says installed. Okay, let me check through the command line, because that way I'll be sure about it whether there's a problem with UI or not. So command line so this is a master server. So qctl get pod all namespaces grep Prometheus. So I'm checking this. Yes, it's coming here. Prometheus is running. And last one, istio. Let me check this. So istio. No, istio did not get installed so far. istio. So Prometheus got installed, but chart istio did not get installed. So I need to check that. So yeah, there's some problem with the Rancher here. It's not updating properly. So I will fix this one later probably. Okay, so here come back to continuous delivery here, and yes, you can install all this DevOps tool and get going. Now you can also implement the CI using the Rancher. So continuous integration happens and managed in your source control systems such as Jenkins, GitLab, GitHub, Azure DevOps, and all these things you can link with Rancher. So CD tools also which you can link with Rancher. So Rancher, what CD tool you have? So CD tool means continuous delivery, which you have fleet. This is the fleet actually. Welcome to fleet continuous delivery. Now, what is a fleet? So basically, fleet, using that you can manage all the containers and application chart packages and all stuff like that. So here the app catalog gives a visual way to configure app and a way to upgrade them. These apps are bundled of Helm chart from the repository. The app catalog gives your teams a shopping like experience to deploy the app. So whatever the app you want to add it, you can add as a git repo. So here you can add a git repo like any charts and sort of it. Okay, you can add it as a chart. This you can check it. You can take it up a Helm chart and you can add as a git repo, and from there anyone can deploy it. So here, if you see that these options, the one which I was showing you, you can install the charts to your any of your namespace. Installing the chart was very simple. So you have to go to this one. I don't have any clusters but local and apps and marketplace. These are the charts which you can deploy. So here you can install more charts, more repository. If you add it here, more charts you can get it here. Okay, so you can install, remove, update, and you can use this. So fleet. Now coming back to again this one, which is continuous delivery. This is the fleet. So what is a fleet? So fleet is a container management and deployment engine designed for better control of Kubernetes cluster and constant monitoring via GitOps. Okay, so this is the area which we have for fleet. Again, same place. And fleet is a separate project separate project from Rancher that was built and maintained by Rancher team. It can be deployed onto any Kubernetes cluster. Fleet comes pre-installed in Rancher and managed by continuous delivery option in the Rancher UI. Fleet is a set of Kubernetes custom resources, which we call it a CRD. So if you want to see that this CRD, go to this local and go to more resources and here, see here. This is the custom resources definitions, and here you will find the fleet. All these APIs for the fleet is here. Okay, so this is the custom resources. So fleet comes pre-installed in Rancher and managed by continuous delivery options in the Rancher UI. Fleet is a set of Kubernetes custom resources definitions, CRDs, and controllers to manage GitOps for the single Kubernetes cluster or many Kubernetes clusters up to 1 million. Now, fleet architecture. So fleet has a two core component. One is a fleet manager, one is a clustered agent. So fleet manager, we call it a cares control running in Kubernetes, and clustered agent, where each clustered under fleet management runs a fleet under a clustered agent that talks with the Kubernetes API of the Kubernetes cluster running fleet. Fleet dynamically creates service account, manage their RBACs, and then process tokens to downstream cluster. Helm is used as the engine in fleet to deploy everything in the cluster. Regardless of the sources, all resources are dynamically turned into Helm chart. So if you see that here, downstream clusters, here you have a cluster group 1, cluster group 2, cluster group 3, and in each of these you can deploy the fleet agent. So at the host machine they'll be having fleet controller manager, which you can see on my cursor, and then agent will be having at every downstream cluster. Now, so how do we go about it? So here you can click on the continuous delivery, select your top or select your workspace at the top of the menus node, and by default you will see fleet default selected, which is include all the downstream Kubernetes cluster that are registered through Rancher. So here, as of now, I don't have. I wanted to register it, but if you go to here, and I have a default, so we don't have any deployment right now because that we did not get this local cluster running. But this is the fleet default, and this is fleet local. Fleet local is for our own Rancher cluster, and fleet default is for the all the downstream cluster. So second thing, fleet local only contains the local cluster Rancher, is deployed to you also. You'll see any workspaces you created. You can then manage clusters by clicking the on clusters on the left navigation bar. Third, click on the Git repos on the left navigation bar and configure a Git repo URL that contain your app's Helm chart. So if you see that here, you go to this one, and here you click on the Git repo and add a repository, and this repository you can add a Helm chart. So any Helm chart app if you have, for example, I'll download some of the Helm chart from Google, that is like Helm chart for Apache. Okay, this is my app, and you can use this one, and where's a GitHub link for it, and this is the, just a second, we need a GitHub link for it here. Okay, so this is the one Helm chart. You can use this one, but it has to be only one. Let me try if this URL will take it up, because till the chart it should consider. So it should be in the .git format. So I need independent Helm chart HTTP. Let me search for it. And probably this one will help me. I need a direct GitHub URL. So it should be I got. So here this one should be okay. Oh, no. I'll take any example. So Helm, GitHub, sample chart. Yeah. So this is let's use this one only for time being. So here HTTP and done. Now authentication none is a public. Helm authentication none. Add path is not required. All this thing let it be and create. So now we have created. Now this will be available for installations for all the clusters whichever we have. So this is the way you can add as many applications as part of the CI/CD options, and this will be available for the fleet default. Fleet default means not a fleet local, but fleet default. So that is what I'm talking about. So here click on the Git repo on the left navigation bar and configure a Git repo URL that contains your app's Helm chart. Select your target clusters or cluster group. Okay, that's a fourth option you have to do. And you can also create a cluster group by clicking on the cluster group on the left navigation. So you should come here, and this is the cluster group you can create. As of now, I don't have any clusters external local one. And here you can create a cluster group. Okay, and in this group here should be refresh. Let me refresh. So now no commit for the branch none. And here you have main branch, so I have to modify and go to Helm 1, and here I have to change the branch. So for that, edit, and here I have to change the branch master instead of main. That was a problem, and save it. Now automatically that will get corrected. Just wait for a few seconds. Yeah, done. Now this one you can force update. You can add more repository under the group. Groups. Now here you can see that what are the resources you want to modify. So you can edit, config, and where is that? Just clusters we don't have, that's a problem. Two options are. So select your target clusters. Saying right now unclustered group. You can also create a cluster group by clicking on the cluster group. Click and save, and app will deploy using the GitOps process. You can monitor the app status via Rancher UI. So this fifth and fourth option we did not get it. Why? Because there's no clusters. That's the problem here. That's the reason we are not able to deploy it. So that is the, so this I'll show you that deployment next demo when the cluster is stable and get going. Okay, now after that we have to understand the centralized app catalog in Rancher. So this chart we have seen it already multiple times, and here the repository, the one which you are adding the chart with, which we have added, last question also. So if you go to here and local and apps and marketplace repository. So here this you can add also. At this is you are adding to the local. So you can add a repository that can be HTTP and GET based chart repository. So both it can be added. And Rancher supports two different types of chart: Helm chart and Rancher chart. So Rancher charts are based on native Helm chart, but enhance user experience in Rancher when deploying an app. Rancher chart adds simplified chart uh, description and configuration form to make the application deployment easy. So if you see that, what is a Helm chart, what is a Rancher chart? So if you come back here and if you see that these all are Helm chart actually. Let me show you if I get a Rancher chart. I don't think so we have. I'm seeing that config. No. Okay, so there's two kind of chart. Most of the time we use the Helm chart only, the one which I'm using multiple times. Now this is a Helm chart directory structure. So you'll have application name, app version, chart.yaml, requirement.yaml, values.yaml, and templates. So this you can easily create it using the command line also, and that command line is the command line is go to the OPT, and I believe Helm is installed. So yeah. So now mkdir Raju cd Raju, and here you just type Helm init. Helm init. Wait a second. Helm init, and now init command. I'm just looking for this. It's removed in which version of Helm this? Helm. Just a second. So here create. So you can use the create command instead of init in this version. So Helm create and Raju, and you see that go to Raju, and this whole skeleton which you get it here. Tree is not there, so yum install tree -y. Yeah. So now if you see that this is the same structure, you can find it charts YAML, templates, values.yaml. So if you map this here, every chart will have the same skeleton. We'll have a charts.yaml, values.yaml, templates directory, and all stuff like that. So that you can use this for this. So a Rancher chart will have a two files. One is a questions.yaml and readme.md. Typically, you don't use the Rancher chart, so I'll just ignore it. The Rancher Helm chart form, which you can see over here, and these are notations which you have for Rancher Helm chart. That's all. Okay, so now we have a few demos pending, and the demo which I was planning, like I will deploy the clusters and and then followed by create a projects, nodes, and some deploy some apps and stuff like that. So there's some problem in the clusters. So I'll do one thing. I'll fix this offline and I'll let you know. And the remaining demo only we have a demo, no discussions. That like deploying the clusters and using the clusters for deploying the workload and so on, apps and all, which we have to do that. So can we do that in the next class? So
Yes, but how many days?
so I have
Hello,
a
can you
3
hear
to
me?
4 demo. I think 3 to 4 hours of demo.
Yeah.
So
But when?
tomorrow we'll sit for 2 hours. Tomorrow we'll sit for 2 hours and we'll try to give you the complete demo. Okay.
Yes. Okay. But
Okay. So the
when we?
theoretical part is over. It's just we need to deploy a few clusters and then create a projects, namespaces, nodes, cluster members, and all these features. And accordingly, you have to use it.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.